Hey, what's going on, guys? Let's do this problem right here. The question is asking find the magnetic field at a point a distance r away from a wire of length 2a carrying a current I. The point is directly across the midpoint of the wire. And let's see how we can find the magnetic field using this information, right? Let's go ahead and draw the diagram for this one first. First of all, they are saying this distance is r away from a wire, so we have a distance. So let's draw the wire first. So this is a wire, right? R away and 2a, the length is 2a, and then we have this, the point is directly across the midpoint of the wire, so the magnetic field is from the midpoint and the distance is capital R, right? And then what else we have? We have the distance 2a, length of this wire. So if I take this point as 0, we are going to have a right here, a distance from 0 to bottom and a distance from 0 to top. So we are going to have two distance, and also they have given carrying current I. Okay, so the current is going through this wire, so the current is in this direction. Okay, now to find the magnetic field's direction, what we do, we take our right hand and point thumb toward this current's direction. So if you point your thumb using your right hand, if you point your thumb and then bend your hand, this is your fingers are going to be inside, right? Facing, it's hard to draw right here, but your fingers are going to be facing inside this screen. So this is going to be inside, so we can put cross right here. So this is the magnetic field we are trying to find. But in order to do that, what we can do is we can take a small portion, let's say a small segment of this wire, and find the magnetic field of that one. So let's say the distance from here is y, here to here is y, and this distance is r, and we know the magnetic field equation, that is V is equal to mu naught q v cross r, right, divided by 4 pi r square. So this is the V equation we are going to use, but let's see how we can find it. First of all, I can rewrite this equation in a different way, like using sin theta instead of this cross r, right? So this is going to be mu naught qv sin theta over 4 pi r square. Since they are talking about current and the distance, we can rewrite this in a different way. Like, we know that q is equal to I is equal to q over t. So let's write that one right here. We know that I is equal to q over dt, and we know that velocity is equal to x over dt, right? And here we are dealing with qv, so this is the one we are trying to replace. So instead of q is equal, therefore from this one we know that q is equal to I dt, right? I dt, therefore qv is equal to I dt times x over dt, and from this one dt cancels, we are left with ix, and the x is going to be distance of this segment, that is from actually the length of this segment, that is, if this is dy, this is going to be dy. So this is dy, that's the length we are going to put, I dy, and we can replace this equation with mu naught I dy sin theta over 4 pi r square, right? 4 pi r square. So let's say this is the angle theta, the angle that's making with segment. This is theta. If this is theta, then the opposite is going to be r, right? Opposite is going to be r sin theta, opposite is r, and the and hypotenuse is smaller, so r over small r. Now we can replace this one with r over small r, so this is going to be r over r cube. But before we do that, we can do one more thing. We can find this r in terms of this capital R and this y. So this is going to be r is going to be equal to r square plus y square square root, right? Pythagorean theorem. So here we have r square plus y square. Now let's replace this one with this. This is going to be, so we are finding that dB right now. So this is related to this small segment. Now to find the total magnetic field, we just have to integrate this one after we finding this one. So let's find the dB first, then we do the integration, right? So here we have these informations. Now let's replace this r with these values. So here we are going to get mu naught I dy sine theta over 4 phi r square. So 4 phi remains the same. R square is going to be square root of r square plus y square square. When we square this one, this square is going to be cancelled. So we only get r square plus y square. So this is going to be r square plus y square right here, right? Now let's apply the sine theta. If I put the sine theta mu naught I dy, and instead of sine theta, if I place r over r in the denominator 4 phi, and instead of this r I can put this one right here. It's r square plus y square. If it's square root, it means power half, right? So this is going to be power half. R square plus y square, r square plus y square, power half. So this is what we have. Let's continue this one right here, and let's see what we get. So here we are going to get mu naught I dy r over 4 phi r square plus y square power 1 plus half. So this is going to be 1.5 is same as 3 by 2, right? Now we have this information right here. So this is for dB. Now instead to find the total magnetic field, we have to integrate this one. So let's do the integration here. So if we integrate, everything except y is going to be constant because we have dy, so we can only integrate y values. So let's do the integration. So b is going to be, I'm taking 0 to a. So if I take 0 to a, I have to multiply this one by 2 because the currents and the wire's length is 2a. 0 to a is half of it, right? So in order to get the full magnetic field, we have to multiply this one by 2. So this is going to be 2 times integral 0 to a dB, right? I'm going to integrate this one. So let's plug the values. So this is going to be 2 times integration 0 to a mu naught I dy I r dy over 4 phi r square plus y square power 3 by 2. That's it. And everything except y is going to be constant. We can move everything front. So this is going to be 2 mu naught IR over 4 phi. So now 4 phi and this 2 cancels. This is going to be just 2 phi, right? 2 phi right here. And here we are going to have integral 0 to a. This is just going to be dy over r square plus y square power 3 by 2. So this is what we have. Let's simplify this one. Now if we do the integration, for this one, this is going to be r. Okay, let's do this. This is going to be mu naught IR over 2 phi. If we integrate this one, this is going to give us y over r times r square plus y square power half. So this is what we get when we do the integration, and it's going from 0 to a, right? Let's plug the a first. So this is gonna be mu naught IR over 2 phi a over r times r square plus a square power half. And then if we plug 0, that's going to be just 0, so we can just subtract 0. That's not going to change anything. So let's continue this one right here. Here we have mu naught IR over 2 phi, and let's cancel everything we can cancel. So from this one we can see that r and r cancels. Mu naught I a over these things left. So let's write this one right here. Mu naught I over IA over 2 phi r square plus a square power half, and this is going to be the final value, right? And what happens if the r is too big? I mean, if the a is big, let's say if the a is big, a value is big and r value is small, this is going to become mu naught I over 2 phi a over r power a square power half. So this is just going to be mu naught I over 2 phi a over ra, that is same as mu naught I over 2 phi r, right? And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.